Okay, we're moving on now that we have an idea of how to take the derivatives and how to apply derivatives to functions. We're going to start looking at the two other types of functions that we haven't yet talked about. Before we dealt with radicals, we dealt with rational functions, we dealt with polynomial functions. Now we need to move to exponentials, and after the exponentials and the logarithmic functions, we'll take a look at the trig functions. Okay, so let's go ahead and take a look at the derivative of what is called the exponential function, or e to the x. Now the interesting thing about the derivative of f of x equals e to the x is that it is actually its own derivative. So what happens then is that we say that if f of x is equal to e to the x, then the derivative is actually e to the x. So that's a very nice result because it's so simple. The thing though is that we have to make sure that when you actually go ahead and take the derivative of any exponential function is you have to be able to also apply all the other rules of differentiation to it, and in particular the chain rule. So let's just take a look at a couple of examples here, and let's make sure that everybody can see how to calculate the derivative given an exponential function. Take a look at this first one here. It says y is equal to e to the 4x. Now hopefully everybody is recognizing that this is actually a composition of functions because the 4x is the composite part. Okay, so what we have then is that if we actually take the derivative of e to the 4x, the derivative of e to the 4x is just going to be e to the 4x just like we have here, except for what we have to do after that is take the derivative of the part that is the composite part. So what that means then is that we also have to multiply it by the derivative of 4x, which is 4. So the derivative of y is equal to e to the 4x is going to be 4 times it by e to the 4x. Okay, let's take a look at b. b says what happens if you have y is equal to 2 times it by e to the negative pi over 2. And notice that what we come up with in this case is that d of y over d of x is actually equal to 0. Now how is that actually equal to 0? Well, the reason why that's actually equal to 0 is because this actually is a constant. There's no x value in it. So this is just a number. If you put it into your calculator, it's just a number. So what that means then is that this whole thing, even though it looks very complicated, is really just a number. So the derivative of a constant, as we know, is always 0. Let's go ahead and take a look at y is equal to e to the negative x squared. Now again, what we should be able to recognize is that this is a composition of functions with f of x is equal to e to the x and g of x being equal to negative x squared. So if I go ahead and take the derivative of y with respect to x, it's going to be e to the negative x squared, right? It's just going to be the same thing, times it by the derivative of that part there, and the derivative of that part is just minus 2x. So we come out with negative 2x e to the negative 2x. Oh, sorry, negative 2x e to the negative x squared. Okay, let's take a look at d. Again, notice that this is again a composition of functions, and what we have here is the derivative, which is going to be e to the 2x plus 1. Notice again that we just repeat this part, times it by the derivative of that exponential part. So the derivative of that 2x plus 1 is just going to be 2. So we come out with d of y over d of x being equal to 2e to the 2x plus 1. Okay, now we also need to go ahead and be able to find the derivative if, say for example, the exponential function is actually multiplied to a polynomial function. And so notice we have the product rule here, and within the product rule we have the chain rule because this right here is going to be a composition of functions. So let's go ahead and take a look at the product rule. I'm going to hold this one constant first, take the derivative of this one here, that's going to be e to the 3x times it by the derivative of that, which is 3, plus I'm going to take the derivative of this, which is going to be 2x, times it by 3x, e to the 3x. So if I simplify that, that becomes 3x squared e to the 3x plus 2x e to the 3x. And of course, remember, as we always said before, is you want to factorize if possible. So if we factorize that, we come up with x e to the 3x times by 3x plus 2. Okay? Let's take a look at the last one that we have here. This is f. This one says, what if you have a function y is equal to the square root of e to the 2x plus 10? And notice that this is strictly just a chain rule. Let's go ahead and change the form of that. and that's going to be e to the 2x plus 10 raised to the 1/2 power. If we take the derivative of that, that's going to be 1/2 e to the 2x plus 10 to the negative 1/2 power, times it by the derivative of this. Now notice that the derivative of this here is actually again going to be a chain rule, so I have to take e to the 2x times it by the derivative of that, which is 2, plus the derivative of a constant, which is of course going to be 0. So what I have now is that this 2 here, being that this is 0, we don't have to add anything. This 2 here can cancel out with the 1/2 here, and I have e to the 2x times it by e to the 2x plus 10 to the negative 1/2 power. That can be simplified to e to the 2x divided by the square root of e to the 2x plus 10. Okay, so there you go. That's how you take the derivative of an exponential function. Now, in addition to that, in the next section, there's a review section with regards to natural logarithms. You're going to have to look over that section on your own, because of course that section is going to be review. But it's going to be important that you review that section, because of course you're going to have to actually solve for these exponential values as well. And that means using the logarithmic function as well. Okay, so take a look at that, and we'll see how everybody does with this section. Alright, good luck, and let's see how you do. Okay, bye.